I want us to talk about trigonometric functions. Notice I have a right triangle drawn here. I have a triangle labeled A, B, and C. C is the right angle. The side opposite angle A is lowercase a. Lowercase a represents the side BC. The side opposite angle B is lowercase b, which represents the side AC. And side C is the side opposite angle C, represented by AB. The two legs, A and B, are closest to, and they are adjacent to angle C. In other words, they're right next to angle C. So A and B are your legs. The side opposite the right angle, which is C, is the hypotenuse. Now we will be using the Pythagorean theorem that we've used previously. A squared plus B squared equals C squared. We'll be using that a little later on. Remember, you use the Pythagorean theorem to determine a side of the triangle. Here we have theta. Theta represents angle A. Now, in this problem, they're talking about the 6 trigonometric functions of the acute angle theta. The first one is sine of theta. Sine of theta is the length of the opposite side of angle theta divided by the length of the hypotenuse. Well, if you're finding sine of theta, it is the opposite side of and over the hypotenuse. So for theta, the opposite side would be A, the hypotenuse would be C. So that's where we get A over C. So to find sine of theta, we would use A over C. Cosine is the length of the side adjacent to angle theta over the length of the hypotenuse. So for cosine of A, you use the adjacent side, which would be B, over the hypotenuse, which is C. To find tangent of theta, it's the length of the side of the opposite angle theta over the length of the side of the adjacent to angle theta. So, in order to find tangent of theta, it would be opposite A divided by adjacent B. You may have heard the old saying, Oscar had a heap of apples. O for opposite, H for hypotenuse, A for adjacent, H for hypotenuse, O for opposite, and A for adjacent. Oscar had a heap of apples. That's the order that sine, cosine, and tangent come in. Now, next we have cosecant, secant, and cotangent. All right? These are actually reciprocals of sine, cosine, and tangent. If you look, the way you find cosecant is the hypotenuse over the opposite, still using theta. So for cosecant of theta is the hypotenuse, which is C, over the opposite, which is A, C over A. Notice that sine was A over C. Cosecant is C over A. They're reciprocals of one another, sine and cosecant. Cosine and secant are the same way. They're reciprocals of one another. To find secant, it's hypotenuse over adjacent. Hypotenuse of theta is C. Adjacent of theta is B. So that's where we get C over B. Recall that cosine was B divided by C. But the reciprocal of cosine, which is secant, is C over B. And last, cotangent. Cotangent is the length of the adjacent side over the length of the side opposite to angle theta. So we have, going to theta, adjacent would be B, over opposite would be A. So Cotangent of theta is b over a, and it is the reciprocal of tangent, which was a over b. Now these 6 trig functions we will need to memorize. We will need to be able to determine sine, cosine, tangent, cosecant, secant, and cotangent of a specific angle theta. So, with that in mind, let's look at this problem that I have drawn for us. I've given you a right triangle. I've given you all the sides. Here's theta. The side opposite theta is 3. The side adjacent to theta is 4. And the hypotenuse is 5. Okay? Now, we're to find sine, cosine, and tangent. Now, remember the saying, Oscar had a heap of apples. If you want to write that somewhere, Oscar had a heap of apples. Okay? Now, we'll use that. Oscar had for sine, a heap for cosine, of apples for tangent. Oscar had a heap of apples. This is sine, cosine, and tangent. Okay? Now, so using our values from our triangle, sine of theta. Here's theta. Here's angle theta. Opposite theta is 3. The hypotenuse is 5. The hypotenuse will always be the largest of the 3 sides. The hypotenuse will always be the side opposite the right angle. Okay? So sine is 3/5. Cosine of theta. Adjacent. The adjacent side is 4 over the hypotenuse is 5. So your cosine is 4/5. Tangent of theta is opposite 3 divided by adjacent, which is 4. Okay? Now, let's talk a minute. Again, sine was Oscar had, cosine a heap, tangent of apples. Another quick way to get tangent is just take the 2 numerators of sine and cosine. 3 divided by 4. That's another way. That's still opposite over adjacent. Now, remember, I just said that these 3 are reciprocals of the previous ones. So, if sine is Oscar had, if it is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. Cotangent is the reciprocal of tangent. If tangent is opposite over adjacent, then cotangent is adjacent over hypotenuse. So we can go back to our triangle and determine cosine. Cosine of theta, using theta as our angle. Hypotenuse, which is 5, over our opposite, which is 3. Okay? Our secant of theta is the hypotenuse, 5, over adjacent to theta is 4. And cotangent is adjacent, 4, over opposite, 3. So I get cosecant to be 5/3, which is the reciprocal of sine. Secant is 5/4, which is the reciprocal of cosine. And cotangent is 4/3, which is the reciprocal of 3/4. So we have found all 6 trig functions, sine, cosine, tangent, cosecant, secant, and cotangent of this right triangle.